Alright guys, we are officially on to section 4.2, graphing a quadratic function in Vertex or Intercept form. So by the end of the lesson, you should be able to say that you can accomplish that. This is a really good slide for you guys to hit pause on. Lots of good notes on this. This is also in your textbook in case you need to see something in front of you. This is vertex form. Y equals a times x minus h squared plus k. Last section we dealt with standard form, which is above here. Y equals ax squared plus bx plus c. Vertex form is nice because it lets you pull off the vertex without having to monkey around with negative b over 2a. Here is the form. The vertex that I can actually just write right off of the equation is the point hk. The h comes from whatever is in that parentheses with x. I want you guys to notice how in the equation it's a negative, but when we write the actual vertex, it's a positive. Make sure you pull off the opposite. And again, that k value, whatever is up there, that becomes our k value, whatever's at the end of your equation. It could also be in the beginning if they're being tricky. Just make sure you look for whatever is either added or subtracted onto your function. And we'll show you some examples. The axis of symmetry is x equals h. Okay, so whatever your h value is, set it equal to x and you have your axis of symmetry. The graph opens up if a, again, that number in front of the parentheses, it's still an a here. If it's positive, it opens up. Negative, it opens down. Okay, here's our first example. So what we want to do when we graph a function like this is we want to pull the vertex right off of there. So what I notice is I notice first that that value in front of my parentheses is a negative. So that means my parabola is going to face down. Good to know. Now we have to pull off that vertex. I'm going to take whatever is inside the parentheses next to x. I'm going to pull off the opposite. I see a positive 2. Let's pull out a negative 2. That's my h value. My k is whatever is at the end. And this one I don't have to worry about the opposite. I just put whatever it is. Okay, so right now what I can say is that my parabola has a vertex at negative 2, 5. There's the vertex. The axis of symmetry is whatever that x value is, negative 2. Okay? So now all that's left to do is to find that extra point. And unfortunately for this one, it does not work to put whatever value is at the end of your function as your y-intercept. So what we have to do is pick one x value, plug it into our equation, and then use symmetry to get the other one. So let's pick, I don't know, I'm kind of looking at the fact that my graph is going to open down, and it's going to be on both sides of this axis of symmetry, so I think I might hit 0. See where it does cross. So I'm going to put 0 in for x. So I'm going to go y equals negative 1/4 0 plus 2 squared plus 5. 0 plus 2 is 2. 2 squared is 4. So negative 1/4 times 4 plus 5. That is going to be, remember, fractions multiply straight across. Negative 1 plus 5 or 4. So one of the points I can put on my graph is 0, 4. Notice that is a y-intercept, but we had to actually calculate it this time. So 0, 4. Now I can use symmetry to get the other point. I notice that this point is 1, 2 away. I'm going to go on the other side. 1, 2, and put a dot. And done. Just make sure you get that same U-shaped graph. Alright, the other form that we're dealing with today is intercept form. Intercept form talks about where your parabola is going to intersect the x-axis. Okay? Intercept form looks like this. You have Notice how x is repeated twice. That's okay. You're going to have parentheses with x minus your two intercepts. Remember, guys, how we talked about where the graph crosses the x-axis? Those are your factors or your zeros. So it's almost like you're taking a graph that's already in factored form and graphing it right away. Again, that a value is going to tell you if your graph opens up or down. Again, if it's positive or negative. Positive opens up, negative opens down. Here, the axis of symmetry is halfway between those intercepts. So it has the equation p plus q over 2. So we pull out the opposite of p, pull out the opposite of q, add them together and divide by 2. That gives us our axis of symmetry. Again, this is a very good slide to hit pause and write down this information or get it right out of your textbook. Here's an example of graphing a quadratic in intercept form. Our very first step is to figure out what those intercepts are. So I'm going to look at what is right next to x in my parentheses. Anytime you're graphing and it involves parentheses and you're pulling something out of the inside of those parentheses, you pull out the opposite. So here, our first intercept, opposite of positive 3 is negative 3. Here, our second intercept is positive 1. So I'm going to go on the x-axis and plot the point negative 3, 0, 1, 0. Whenever you have an x-intercept, y is 0. So negative 3, 0, 1, 0.